Christian. Now we move on to the last presentation today. It will be given by Holger Zeltwanger. And Holger Zeltwanger finished in 1976 his studies at the University of Applied Science in Braunschweig-Wolfenbüttel in Germany with a diploma in electronic engineering. He worked at Siemens as a system programmer for 2 years. After that, he was for more than 14 years an editor of several technical magazines. In 1992, he initiated the CAN in automation called SIA, International Users and Manufacturers Group. Since the beginning, he is the SIA Managing Director elected annually. He's also a member of multiple standardization groups and convenes the ISO TC22 Subcommittee 31 Working Group 3. That means in-vehicle networking, and Working Group 4, which means network applications. And not just that, I think also Holger is for sure the best known person in the CAN community. Everybody knows Holger. So Holger, thank you that you give us today a presentation, and it will be about the standardized layer management options for CAN-based networks. So I'm looking forward to your talk, Holger.
Thank you, Arthur, for the welcome. And I will start with this presentation. But before I start, I will give you a little bit of background on why I have this presentation prepared. When I see all these new upcoming things regarding CAN XL, all the new functions and all the things, I was struggling to understand this properly and how to educate this. And you know that I'm mainly, from my work career, I was for many years an editor, and I'm always struggling with not consistent terminology and all the things, and also with the modeling, which is sometimes challenging to understand what all the nice features are. I try to bring a little bit light into this jungle so that we can see at the end a single plant or a single tree and not just the jungle. So I went back to the roots, and the roots are the open system interconnection model, which was developed a couple of years ago, or let's say decades ago. And everybody is knowing it. And this is the 7-layer architecture, starting from the physical layer up to the application layer. And each of these layers provide a specific functionality. This is well known. Everybody uses it for teaching services or for documentation. Everybody make reference to this. Of course, the open system interconnection model is standardized somewhere, and it is standardized in the ISO 7498 series. But I'm not sure how many people have really read this document and understood it and used that what is written in this document. And this document is mainly a framework. It doesn't specify something specific, but still the framework is needed to understand things. I just dived into the history, and the first idea was born in the mid of the 70s when I finished my university. And I learned already in those days that there is some ongoing activity. And in 1977, there was the first ISO meeting regarding a layered communication model. 1 year later, Hubert Zimmermann, who sounds very German but is a French one, proposed a first model. 5 years later, you can imagine that this is a long time, there was 2 organizations dealing with communication modeling, and they merged their activities. This were the CCITT and the ISO. CCITT is mainly from the telecommunication industry, and ISO is more in general for the standardization body of things which are not electrical. In 1948, there was the first version published of ISO 7498. And in parallel, the other organization from the telecom industry, they published the same document as X.200. 5 years later, when there was the first systematic review, the document was split in different parts. The first part was still that what is in the basic, on the first edition, the basic model. And this was the last time corrected in 1996. part 2, and already in 1989, there was a part 2 describing a security architecture, which was confirmed in 2000 and never touched again. The part 3, which specified then naming and addressing, this was withdrawn because of not relevance. Part 4 is still valid and was confirmed in 2006 and describes the management framework. I will go through some of these ideas and I will look how this fits to the CAN communication. So just to give those which are not that familiar with the OSI reference model, the idea what is behind that, and this is very simple. You have some information like from this tachograph, which you want to communicate to somebody else. You pack this in boxes with different functionality, and then you provide this to a server who sends this by means of any transportation. This transportation can be an electrical wire, it could be an optical wire, it could be a wireless communication, it doesn't matter. So this model fits to all kinds of communications, even to human communications. And the receiver unpacks this box by box, and at the end, he has the information he looks for. This is, for example, the tachograph information or the data. This seems to be very, very simple. But if you're going in more detail, then you see that this is more abstract, solved in the ISO 7498 model. We have seen a similar figure in the presentation from Christian. So I distinguish between the different layers, as well as that what is the application. And the application provides to me, as a protocol stack for communication, a data SDU. SDU stands for service data unit. So this is some parameter or a group of parameters. And this could be, of course, PDUs or multi-PDUs or whatever it is. So this is something, and then this is put into the container of the application layer. And the application layer adds some header and footer information. This is, so to say, the box or the envelope or however you like to see that. And this is forwarded then to the next one as a PDU. So the protocol data unit is depends on the different layers. So we have all layers, we have a PDU. So this makes it sometimes confusing when we use the PDU without as a general term and not with a specific term for each layer. So the PDU from the application layer combines the data SDU and the header and the footer information provided by the application layer, and so on. This goes down to the layer 2, and here you see that we have already then layer 3 SDU, and we add some additional things like the start of frame bit and so on if we are going to CAN. But this is a generic approach, and this fits to all communication systems. And of course, the physical layer transmits just symbols, and that symbols can be any kind of coded information which are going via the bus lines or the air if this is a wireless communication system. So what's about the layer configuration, which I already mentioned? Do we need that? And if we need that, what are the options which we have? There's first of all, layer management, which is static. This is done if you just have a which provides the communication interfaces. Additionally, it could be that you sometimes need a remote layer management because you want to change the layer specification. 3 options are described in part 4 of the 7498 OSI model standard. First one is that you have a separate interface to configure your communication interface. The second one is that you use dedicated layer configuration protocols on the normal communication interface. And third one is that you embed the layer management information into the normal communication protocols. To understand this, is important, and to remind that, because we are using all three things in CAN XL and some other CAN communication systems. So what had this to do with CAN? Going step by step from the abstract model to a CAN-based solution. You see here the OSI layer. So if we are talking about CAN, we are talking only about the lower layers, which are represent the physical layer and the data link layer. Unfortunately, CAN is not 100% compliant to that. This means we have not the same structure when we implement that. Normally, when we implement the data link layer, this is done in some microcontrollers or in some standalone controllers, and they provide the functionality of the logical link control and the medium access control sublayers. This idea has been stolen from the IEEE, which use the same terms for the Ethernet data link layer. Additionally, all CAN controllers on the market provide the physical coding sublayer. This is not part of the data link layer. This is already part of the physical layer. It's also the same idea. It came from IEEE. They also have subdivided the physical layer into different parts. One part is the physical coding sublayer. The other part is the physical media attachment sublayer. And we have the physical media dependent sublayer. The physical media dependent sublayer is normally not standardized in ISO because this is very application specific and is not in the scope of the working group which I'm convening. The physical media attachment, that's what is normally implemented in what we like to call a transceiver, or if you are more familiar with the term in Ethernet technology, it's a PHY, or something like a PHY. So we have two documents in ISO since many years, and 2003 was when we splitted this into two parts. And the part one, this combines the logical link control, the medium access control, and the physical coding. Part two provides the physical media attachment and is implemented normally in the transceiver chips. So far, so good, so easy to understand. So the mapping of CAN to the OSI model. Coming to the configuration of a layer. In the physical in PCS sublayer, we need to configure the bit timing. So we can do this statically, locally on each ECU by means of software drivers or by dip switches or whatever we want to do. So we can even then change the bit time locally from one device to another device. But this is not a good solution if you want to do this for the entire system. Then you need, if you have the requirement to have a dynamic change of the bit timing configuration, then you need remote access. And you may remember that we have those things available, and we can do that by means of additional interfaces. So we can introduce a USB interface for all the different ECUs in the network and provide the new bit timing configuration. But from the beginning, CIA was already thinking that this is not a good idea. So to make it consistent, then we have to develop special protocols running on the very same CAN interface as the normal communication. Already in 1992, we specified the layer management LMT, abbreviated LMT layer. And this is specified in CIA 205. We have the same done or similar done for CAN Open, the layer setting services specified in CIA 305, and for CAN Open FD in the specification CIA 1305. We have done this also now in the ISO. We have in ISO 15766-5. We have also bit changing dynamically, and the external tool starts always with a classical CAN communication and adjust the bit timing parameters for the supported CAN FD communication dynamically. So you see, this is not something new. We do configuration of layers or sublayers since the beginning of the CAN technology. What's about the data link layer? If you look a little bit closer to that and try to analyze what we are doing, then we have here also some management information. In this case, it is embedded in the protocol. So we have the IDI bit, which distinguishes between the base frame format and the extended frame format for data frames as well as for remote frames. And this is, so to say, if you look at this from the modeling point of view, this is a data link layer management information. Because now we know we're using different protocols and we have to configure that. And we get this information from the upper layers. Similar it is with KNFD protocols. There we have also some lower layer management information embedded in the frame. You see here the IDI bit, the FDF bit, which makes then the protocol that we're using another protocol, not the classical one, but we use then the FD base frame format or the extended frame format. And we have the BRS bit, which is configuring that we are using another bit timing or not. So this is, so to say, these three bits belong to the lower layer management, and it is embedded in the protocol. If we're going now to KNXL, it becomes more complex, and we should distinguish between different embedded information. It's not only that what the higher layer SDU for the normal communication provides. This is just the PID, the acceptance field, and the data field. All the other fields have some other meanings. You see that we have some footer and header information, like the start of frame bit with the RSS bit, the reserve bit, the ADAS bit, all the other things which are yellow. This information is provided by the data link layer, and so to say, the header and footer of the data link layer. We have also additional higher layer management information. We learned already in the morning, in the first session, that we have the SDU type information, that we have a virtual KNID, which is then, so to say, the higher layer management information. And in addition, we have the SEC bit, which introduces some additional services not used for the normal communication, but for an additional service. And if this is set, this bit, then we use a part of the data field for additional information. And this should be known by the receiver. So you see that now we have 5 different classes of information which we have to mention, all in the same data link layer frame, but they are just embedded sometimes. We have also for KNXL an additional configuration necessary, so that can be done statically by means of software drivers or electromechanical switches or whatever it is, to distinguish between the disabling of and the enabling of error signaling. We can do this also dynamically, but then we would need an additional electronic interface. Maybe you will see that when you are buying the prototype board from the CNS group, that they have an additional KNFD communication on the board just to configure the KNXL communication. We also can disabling or of the default error signaling by means of a special protocol running on the KN interface. So we could use KNXL to inform that we are using now a different configuration in all the nodes. But this is not yet standardized. We can do also this embedded in the data frame, but then we need also to specify it. It's also not done yet. A simple extend content bit provides additional information about features of the add-on services for the data link layer. You have seen in the presentation in the last session that this causes then an additional field, or needs an additional field in the data field where information is embedded. We can also cascade the SEC bit. So this is also intended to be done, and so that we can have different additional services provided by this data link layer implementation. For example, for data link layer fragmentation, for functional safety, and for other services, maybe also sleep mode and those things. We will specify this in the series CIA 613, and this is under progress, and we will see how many different add-on functions we will provide. The ideas are not new, which I have presented. You see here the complexity, what the ISO Technical Committee 204 is promoting. They developed a gateway model for general purposes and in particular for those applications in traffic, and so that you have at the end, you see it on the lower part, that you have a gateway solution for Ethernet, for CAN, for multiple automotive networks. And this general gateway functionality, this should be described somehow. And they have simplified this as much as possible, and you see here the results of their model. We're doing the same or similar thing in the ISO Technical Committee 22, Subcommittee 31. We also try to develop a model for all, which covers all automotive networks in the car, for in-vehicle networking, so to say. You see, it looks also very complex. And this is because of the history. We have too many interfaces, and we have to develop a clear model so that you don't go lost in the jungle of specifications. You can see that we have a lot of applications here from the also for the extended vehicle, where we have information then outside of the vehicle, which belongs to the vehicle, like repair information, and all the things are and you see that this is something, a nightmare to manage all the documents and keep them consistent. So my proposal is to keep it as simple as CAN is. So we have a extended open system interconnection model for CAN. Very simple. We have an application, we have communication services, and the communication services are normally described by service access points. So we have the OSI layer 7 to 5, which are normally called the upper layers. Then we have the transport layer, and we have the network layer. And I have a dotted line in between because sometimes this is not distinguished in some of the documents, and we can regard this as one piece of implementation. Then we have the CAN data link layer, we have the CAN transceiver, and we have the physical media. So some of them needs configuration. We can still do this statically by means of service access points, could be separate networks, could be just a local software driver, or some electromechanical equipment which configures all these layers. Of course, we also need to do this remotely, and therefore we need from the application sometimes additional layer management protocols, or we embed those information into the frames, segments, messages, or whatever it is. And in addition, we have the add-on services. There are a lot of add-on services, and we talked about security and safety, and maybe others will also include then the fragmentation on the data link layer. This could be done also for the other layers, and this also can be done statically, so locally in each of the nodes, or remotely by means of an interface to the application and appropriate service access points. So what we are proposing from CIA is that we need a series of documents It will be maybe at the end not standards and specifications. It will be maybe technical reports, how to model CAN lower layers and CAN-based higher layers. So in line with this ISO 7498 series, so that we can describe jointly and consistently the service access points for all the different solutions which are on the market. This should be done for the normal communication, for the layer management, and for the add-on services, such as security, frame fragmentation, and sleep mode. This series could comprise the following parts. It's just a proposal, and when we are going to develop those documents, then we will see if this is a proper solution or if we have to adjust this. We need a part for the CAN lower layers. So this work item is already initiated. We have the part 2 for CAN open and CAN open FD higher layers, maybe for J939 based higher layers, and also for those documents which are in the hands of the ISO. Maybe that ISO is going by themselves to do such a modeling. We will see how good we can harmonize all these activities. Just to get a better understanding on the scope of part 1, this document models the CAN data link layers specified in ISO 11898-1 and CIA 610-1, which is CAN XL, using the definitions given in the ISO 7498 series. It also includes special descriptions of service access points for normal communication services and OC layer management service, as well as additional data link layer services, such as security, data frame fragmentation, and sleep mode. It's important to have the same kind of description of those service access points. If you have this differently for all these, then you can't get a good understanding on what is a service access point. And we can learn from the IT industry, from the telecom industry. They have done a lot of these things, and we can just reuse those things, adapted, of course, to CAN communication. Additionally, this document describes the CAN physical layer as specified in ISO 11898-1 and -2, and maybe others from CIA, using the definitions given in ISO 7498 series. And this includes, of course, the layer management service options for configuring the bit timing and the PWM coding, which is used in CAN XL. In the annexes of such a document, there could be provided implementation examples of the CAN lower layer so that you get an understanding what is really the implementation for the engineers and what is the modeling for those who make the standards and the specifications, and also maybe for the professors and other teachers which try to get new people into the CAN community, understanding what we have all in our pipeline and what is all already standardized. So to summarize, the proposed layer management modeling for CAN-based network is intended to improve a common understanding of specifications as well as standards, and to simplify the education of them. The proposed specification of serious access points for CAN-based networks enables a harmonized description of add-on communication services such as cybersecurity, CAN data link layer fragmentation, sleep mode, etc. So this is the end of my presentation.